Good morning and welcome to episode 3 of the CARIC Resilient Power webinar series for 2021. My name is Martin Ford and I'm the community leader of the CARILEC Renewable Energy Community. And so we've put together this series to discuss how electric utilities are building resilience and how we connect to other industries, seeing that electricity is the glue between much of the infrastructure. So today's session is entitled Building Climate Resilience Now for a Brighter Future, the story of San Andres, Providencia, and Santa Catalina. And I have the distinct honor of welcoming my guests from EEDAS, Mr. Randy Bent, Ms. Camilla Gary, and Mr. Edward J. Welcome to the session. How are you guys doing?
Morning. Thank you, Martin, and thank you for the opportunity, the group of CARILEC, for having us here with you.
Yes, of course, it's an honor. Thank you for reaching out to the CARILEC body and joining us, and your contribution will only make us stronger. So before I hand over to you guys, I just wanted to speak to the audience a bit. All the webinars that we do and have done since we started in 2016 are located on the CARIC community. If you are not currently a member of CARIC, you can go to community.carilec.org and sign up for free. On there, we will be able to continue the discussion using the forum if we can't answer your questions today within the allotted time. So if you do have questions, what you want to do is submit them to the Q&A segment of the panel, and I'll monitor them for the Q&A segment after the EEDAS team has finished presenting. And then, like I said, if there are any extra questions that we cannot get to in this time, we'll be sure to follow up with their team and connect you through the platform. So I'll pass over to you, Randy. I want to know how did EEDAS get into the energy space?
Okay, thank you, Martin. Thank you, all of you. Well, basically, EEDAS was created in 2007, approximately. Was created beyond the interest to develop the energy service in the island and the archipelago of San Andres, Providence, and Catalina. We have been struggling with the way to get the service of energy in the islands. So the Colombian government designed in view of the law 142 the way that they wanted to develop the system in the whole nation as a public service, and they put it also as a possibility of developing what they know as the not connected zones to the electric system. So EEDAS was the one chosen or created to give the service a transitory vehicle, and then in the 2010 they create a concession to develop the public service of energy, where a private or utility company by the name of SOPESA took over the service. And EEDAS have the function as supervisor of the well done or the well do of the service. But then in 2016, approximately, we started to look around the development of the way of clean energy and using of renewables all worldwide. And being our archipelago marine reserve declared so by the ONU, we took the determination to change our framework and look forward to turning to using renewable of the way of be a sustainable public service in the archipelago. And therefore is where we got the opportunity to change our vision, our mentality, and recently we changed our image, turning it into EEDAS Clean Energy. So that's where we come from, and that's where we are more or less we trying to do.
That's thank you for sharing that. Well, I actually wanted to also, before I hand over to Camilla, I wanted to ask the audience a question so that you guys can understand a bit about them, who's joining us. So just going to issue a poll right now. We want to know where you're joining us from, and then what segment or industry might you be from. Just gonna give it a few more seconds. I realized a slight mistake there. We didn't put in the Caribbean one. That's my bad. I apologize. Okay, so EDAS, the audience seems predominantly from North America, and they stem from nonprofits to research to businesses, with a few utilities in there.
Okay, that's awesome.
Yeah, so I'll hand over to you guys now for the presentation. I'll go on mute and let you go ahead. You can share your screen.
Okay, so thank you, Martin. Thank you for having us. This is Camila here. I'm a junior project manager at EEDAS. With me, we have our general manager, Randy Bent, and our technical manager, Edward J. We are very excited to be here, not only to be sharing our experience after IOTA, but also to share with you all what we have been working on in terms of clean energy projects. And also, we are very excited to join the Caribbean community, or if I should say, to reconnect with the Caribbean community. After the presentation, we will have a Q&A, but in most of the slides, you will find my email. So please feel free to contact me if you have any further questions, or if you have any advice or experience that you want to share with us regarding the project that we will be presenting to you all, and about our recovery from IOTA. So we want to start off by giving you a brief introduction about the archipelago of San Andres, Port Providence, and Catalina Islands. As you can see in the map, we are approximately located 466 miles from the mainland Colombia and approximately 490 miles from Jamaica. The archipelago is formed by three main islands. The bigger one is San Andres or St. Andrew. The second one in size is Port Providence, and we also have Santa Catalina or Catalina, which is connected to Providence by a pedestrian bridge. Our mother tongue is Creole, Caribbean English, but our education is 100% in Spanish. And as you can see in the map, we are obviously considered one of the non-interconnected zones in Colombia. So the generation of energy here in the island is mainly 99% by diesel. So, which represent 33% of all of the emissions of CO2 here in the department. Also, the national government of Colombia is covering right now 55% of the total of the archipelago electric energy user fee. By 2019, we reached an energy consumption of almost 196 million kilowatt hour, which means that the government paid over $23.7 million in subsidies. So how is energy generated here in the archipelago? We have, our generation is 99% diesel. We use approximately 14 million gallons of diesel every year, which represent 135,000 tons of CO2 by year. The islands rely on two diesel centrals. The first one and bigger one is located here in San Andres with an installed capacity of 56 megawatts with 32 megawatt peak demand. And in Providence, we have the other central that works for Providence and Ketlina with a 3.3 megawatts installed capacity with 1.9 megawatts peak demand. The annual consumption of the islands reach up to 219 gigawatt hours, where 95% of this is from San Andres. Here we have a picture of the central in San Andres. It's located in Schooner Bight. As you can see, the bigger central generation plant that we have. And the next picture, the next slide, we have a picture of the generation plant in Old Providence. This one is the one that works for Providence and Ketlina. As you can see, it's smaller. It consists of 3 plants that work for the 2 islands. So what are the challenges that we have here in the archipelago? Every year, we consume more or less 13.5 thousands of gallons per year of diesel, which means we emit 135,000 of tons of CO2 by year, and the government covers 85,000 in subsidies every year. And also, another big challenge that we have here is solid waste. Every day we're producing 70 tons of solid waste here. Another challenge that we have that I don't have here in this slide is that most of the planning in terms of energy or clean energy projects takes place in the mainland Colombia, especially in Bogota, where the conditions are not the same as are here in the islands or in the Caribbean. So it had happened that the projects that have been implemented here not always meet the needs that we have as Caribbean. So that's one of the reasons or one of the things that inspire us more to be working towards achieving one day 100% of clean energy here in the islands. And in the next slide, you're going to see what is our route of change that we've been working on. The first step, we define the goals that we want in place of what I just said a while ago. And partnering with the presidency and Carbon Water Room, we defined some steps. As you can see, step 2, we plan to have at least 8 megawatts of wind energy and 1 megawatt in solar. And then eventually we would like to reach 12 megawatts and in wind, and in solar 20 megawatts. As the last step, we are considering a possible implementation of 70% of storage systems.
Okay. Well, thank you so much, Camila. I guess before we hand over now to Randy, I would ask the audience about their experience with renewable energy. So audience, as you will see, we'd like to know what clean energy projects have you done in your country. You can choose more than one. And EDAS would also like to know if you've partnered with another country to receive advice for your project that you implemented. So I'll just give you a few seconds, a minute to review the poll options and select.
Majority is with storage. Invitó.
Solar. Basically solar.
And if you selected other for the projects you've done, feel free to share them in the chat. Okay, I'm gonna end polling now. So the projects that have been done the most are wind and solar, PV, followed by energy storage, then an emphasis on energy efficiency. And then solar thermal, biogas, microgrids, they all come in around the same. And waste to energy, not so much. I'm really interested in what the other might be. And then 44%, Randy, have partnered with another country to receive advice, and they'd like to share their experience with you. And then 33% have not partnered with a country, but they're still interested in sharing with you. So I'm sure you have some follow-up convos coming out of this webinar.
Yeah, that's good to know.
Yeah. Well, I hand over to you, Randy.
Thank you, Martin.
You're welcome.
So let me speak about a little about us. As said at the beginning, EEDAS is a company that was constituted in 2007 as a transitory mechanism to develop the energy service here in the archipelago, based on a policy developed by the mainland, by the main country of Colombia, known as COMPAS. And the objective basically was to make sustainable the public service of energy in San Andres and Providencia Islands and Catalina. The areas between 2008 and 2010, it was the one that provided public service of light or energy in the islands. Then in 2010, they create a contract with a concessionary by the name of SOPESA, who is the one that will be giving the service in the archipelago until 2030, and they are the one that have been making part of the utilities. We are the one that do the auditing of the service of public energy during this period until 2030, and we also do the auditing of the place that they use here to dispose solid residues, we know as Magic Garden. As I speak before, well, I said before, we are part of the Seafloor Alliance, which is the biosphere reserve that was constituted by the ONU in matter of the territory of the archipelago. And in behalf of that, being part of that alliance, we decided to work in matter of renewable energy efficiency, and we have been developing projects in that path, trying to meet our vision or our mission that we constitute in the company. As Camila said also at the beginning, one of our big challenge or one of our big goals is to reconnect with the Caribbean islands, is reconnect with the Caribbean countries, because historically and culturally we consider ourselves, and we know that we are part of the Caribbean community. Politically, maybe certain things show us apart, but we are ready to reconnect and to go back home. In other words, so that's our goal from EEDAS, trying to do it using the technology and the public service as a first step to speak with you all in the same language and sharing in equal interests. So what are we doing, or what we are doing here in the archipelago? EEDAS, as I said before, we are part of the project that handle the solid waste in the islands and do the part of separate it, processing it, and put it to use for create a better environment. We have here in the islands a facility that is the one that storage all this waste, that urban waste that create in the island. It's approximately, we're talking about 412,000 tons there in that facility. This machine have like installed capacity to handle 230 tons per day, but the island produce per day 2.5 tons of solid waste. So the idea of this machine is to make the separation of the waste, organize it, and put it like in a diet or consolidate it in a way that it could be used to generate energy, using a philosophy of WTE. So what we have here in the island basically as solid waste is cardboard, we have paper, we have organics, we have plastic, vegetables. This is the basic dietary that here using the island. And this process, we expect that at the end of the process, you will find something like 60% of rejections that we're going to be adjusting during the testing period. We hope our goal is to get to like 80% of use of this solid waste that could be used, and create like a 20% that will be rejected. Along with this facility, we have another one that work along with it, and is as I displayed before, is a machine or a facility that work that use waste to energy under the philosophy of WTE and RDF. The total waste to process that this machine or this facility could be able to use or are using, we're talking about 80 tons per day. So we produce like 82.5, and we have the possibility to burn the 80 tons per day. So this is a challenge for us, but it's practically guaranteeing that whatever solid that the islands, the archipelago produce, will be able to use in the process of incinerating and creating energy in base of this mechanism or this technology. The installed capacity of this facility is like 1.6 megawatts, and we expect to generate at least 4 gigawatts hour per year, and that will be a contribution like 2.4 to a 4.5% of the whole consume of energy that the islands have, and that will also that we are generating at the moment. Out of this waste, the 90% of it will be used to generate energy, and we're creating like a 10% of waste that they're going to be like ashes that we have to find a way to dispose of it. So in base of that situation, our company or our organization created a project or a philosophy based on the circular economy that we give name as green ashes. What is the philosophy or what is the idea with green ashes? What we're trying to do with these ashes, that this 10% of ashes that will be result of the burning of the machine or using of the machine as solid waste. The idea is to use it in agriculture, use it in pedestrians, walkways, use it in construction and processing, along with investigations that can give us other use or utilities that can be developed in base of these ashes. This process, we are doing it at the moment along with the municipality government of Providencia and the municipality government of San Andres, and it is a project that was inscribed in the data bank of the mainland, the government of Colombia. And at this moment, we are in the last phase of it, trying to get it approved and implemented in the islands. Also, we have a project that we consider it one of our best projects that we have developed, and is a public light solar system. It consists of 180 solar street lights units that was installed in the south part of the island of San Andres. There is something for us to say at this moment in this project, and is that the south part of the island is the one that have the environment that get more affected whenever we have storms, whenever we have any climatology situations, because it's the green part of the island. It's the green part of the island, and historically, we didn't have public light in the area. So we're talking like from this year or from 2020, there was a change in the environment in the area. So, but what we did with this project is that we established a way that the lights won't be affecting the environment. So we have the capacity to increase or decrease the intensity of the light depending on what's going on in the area with the animals that are around there, turtles, iguanas, that they go there to nest and to make the nest and to leave the eggs. So what we do, we can adjust the light so that it don't interfere with the normal way that they develop their production time in the time that they do it. So we're talking about 52 kilowatts per hour installing capacity, and we're helping here with this project to prevent 67.225 kilograms of CO2 per year. So that's what we're doing in that area. We also, at our facilities, our main quarters here in EEDAS, where we are at the moment, we developed a project that have 18 kilowatts per hour based on solar system. And our goal with it is to prevent 23.270 kilograms of CO2 per year. This facility, at the moment, we could say that is preventing, or the consume of the energy that we have here at the facility is the 40% of it is based on solar. So we are depending on the traditional way of energy on diesel, just in at 60%. We also develop a project that we give name as a fisherman place. which is a facility where the fishermen of the island will store their products. And we are trying to make the step over to a clean or a green economy. So in base of that philosophy, and that we know that whenever we get this done, or we get it to start function, because we are in the moment now of we're making the proof them to put it in perfect installation and perfect use to our fishermen. We are trying to get on it that green tag that permit that the product that they handle there will be acceptable worldwide to consume. So what we did, we installed 48 kilowatts per hour solar and wind system. What we did here, we combined both solar energy and wind energy to try to impulse what have to be with the treatment of the product, the way to protect the product, and also the cold rooms that are going to be used during the processing of the product. And this facility permits us to prevent 62,054 kilograms of CO2 per year. The other product that we're going to develop is located in the island of Providencia and Catalina. This project that we're going to be developed is a pedestrian bridge that communicates the two islands. As we explained at the beginning of our presentation, these two islands are nearby, and they communicate through a pedestrian walkway. But in behalf of IOTA, this pedestrian walkway was washed away with the winds and the current that the IOTA present. So what they did is design a new pedestrian bridge. We've been on using concrete and iron. So we take over the idea as how to put illumination on the facility, and we decide to use clean energy to illuminate or put the light on the facility, basing on electric floor, on wind, and on solar system. So basically, what we're going to do here is that whenever the pedestrians cross over from one island to the other, and they transit back and forth, will be the one to help produce the electric energy necessary to put the light to function on this installation. Also, the sun and the wind will be part of it. So it's like a combined matrix that we're going to use here in this facility. Another step that we're doing towards a sustainable clean energy and using renewables in our archipelago have to be with using electric urban vehicles. We decide to try to modify the way that the vehicles or the public service of transportation is used in the islands. So we suggest to the local government and to the national government the possibility of to make a transition to public vehicles and urban transportation to be empowered by electric systems, but not only electric systems, based on the renewable energy. So what we design, we acquire SUVs, we acquire motorcycles and scooters or electric skateboards, with the idea that they will start to show the benefits of using electric vehicles in the island in matter of environmental benefits, in matter of economical benefits, and also to show the new generations that we could help control a little the effect of the change of climate in the world, and especially in our archipelago, using this type of devices. So at the moment, we're working on this, but the key part of this project is not using the traditional energy based on diesel. What we're trying to do here is use solar systems, and we're going to create solar facilities where you could charge your vehicles, both the SUVs, the motors, and the scooters or the electric skateboards. We also working on the possibility of install solar system powering of our hospital here in the island of San Andres. San Andres and Providence have a situation that we were saying that we're talking about 496 miles away from the mainland. So we need to be sustainable in certain things, especially when matter of health. So we have a principal facility or health facility here in the island of San Andres, and we have a small one there in Providence that serves Providence and Catalina. So among the challenges that the health service have, the public energy is one of the main ones. The cost of public energy is one of the main ones. So what we try to do is implement a solar facility that will permit them to have control over the consume of the energy or the cost of energy. We're talking about something like installing 135 kilowatts per hour. And the goal of it is to reduce the dependence of traditional energy from the facility in a 40% of it. That's our goal. And that economical part that we're handling could be used to better the service of, or betterment of the service of health service in the island. What did we do as a protective measures before and during the event of the hurricanes? Because we as a section of the majority of the Caribbean islands, we have not suffered much about hurricanes. We could talk about like 6 or 7 hurricanes between the early 1970s and now with IOTA in the 2020. But Hurricane Beta was one of the ones that strike us heavily or strong, and that occurred in 2005. So that was our point where we start to look about take measures towards the effect of hurricane. So after Beta took place or happens in the island or strike the islands, we upgraded almost the 60% of the low voltage power lines to insulated and aluminum alloy conductors, cables over non-insulated copper cables used before. So we changed our way of the transmission of energy. We passed from the copper cables to alloy conductors. That permits us to protect the way of transmitting the energy to the residences and our high voltage system. As soon as the red alert was emitted by the emergency committee in the island, the system was shut down in order to avoid the risk for falling utility poles and power lines, and to protect the generation system from overloads. That was our first steps. Immediately we knew that something was taking place that was normal in our environment. So it helped us to prevent in certain way the result of the strike of IOTA. But I mean, when we're talking about a category 5, then we're certain things, no matter what you do, certain things gonna be out of your hands and out of the control. From the mainland, San Andres, the mainland is San Andres, and from Colombia, 4 group of personnel and equipment was prepared to be deployed as soon as possible. Have in mind that we couldn't react in the immediate 24 hours or 48 hours after the hurricane strike us, because we're talking about get to the islands either on airplanes or aircraft or through sea. And both situations were a high risk. So we had to react in a matter in a main that we could get the four groups organized and proceed. There was an emergency inventory of the material equipment prepared to reduce the time of actions due to the distance between the islands and mainland, more than 600 kilometers. So the next step that we do was to immediately get to our alliance and make an inventory of the equipment that we had and that we could use to react in front of what taking place in the island. So basically, that was what we did at the moment when IOTA was coming to us, and that we know that was something huge going to happen to the islands.
Before we go in, sorry to interrupt there. I remember we were going to do a poll just to get a sense of the audience before the video. Sorry about that. So we wanted to know if you have experienced a hurricane, and then what category was it, or if you have, experienced another disaster. And you can choose more than one. Right, so just sharing the results with you, Randy, before you go into the video. 47% of the people in the have experienced a hurricane, 53 haven't, and most of them have experienced Cat 1. And so, I mean, a lot of them who have experienced it was a category 1 or 3. But then a lot of people have experienced other natural disasters, and 41% have not experienced. So I just figured you'd want to know that as well. But I'll pass it over to you now for the video.
Okay, thank you, Martin.
Hi, Martin. Well, right now we're going to oversee the aftermath of the Hurricane Iota. Basically, we never experienced before Cat 5 hurricane. The highest level we experienced was in 2005, a Cat 2 hurricane named Beta. And we're going to oversee what we do in generation, distribution, and how to affect renewables during this process.
Sorry. Would you want to ask the audience about their recovery time with hurricanes? Just to give you some context too. I could do that.
Perfect.
Yeah. Sorry about that.
Yes, would be great.
Yeah. So many of you said that you experienced hurricanes, but we kind of wanted to know how long was the recovery time? Just before EEDAS goes into their experience of recovery time. Sure, thank you, everyone. 70% said less than 6 months. However, 10% said 1 to 2 years, and some persons said they're not sure. Is that a surprise to you, Edward?
No, it's in case of, I imagine they're talking about the whole infrastructure. In terms of energy, we handle less time, but that depends on the level of the damage. We are talking on a small island, we are a really small island, so that helps us to recover very fast. But this is times where we have in our minds, they are clear and it's okay.
Okay. All right. Well, just wanted to give you that context. All right. Well, I'll hand over to you. Thanks.
Well, basically in generation, the plant is located in a well-protected area. It's one of the areas that suffer less damage. Basically, affect the rooftop of the gensets, water, and heavy rain. The fuel tanks were contaminated. Several of the pipelines were broke, and the pump station that was at the ground level was damaged. The exhaust system of the one of the gensets, the smallest one, was damaged beyond repair. But the main underground wiring system and the transformer bay was unaffected. In distribution, there was 65% of the medium voltage grid affected, basically for fallen trees, debris, and broken poles. Further, we're going to see deeper this, because one of the biggest challenges we see was the domino effect in the poles. The 70% of the low voltage grid was affected. This mainly was the wiring system, not all the poles. This was 8-meter poles, and basically is the grid of the wiring system that was affected. The 35% of the distribution transformers were affected, mainly for broken structures. As Dr. Randy said before, we turned off the system when the emergency was declared. So electrically, the damage in this equipment was almost zero. but the broken poles or structures affect these transformers. And 90% of the user connections were affected basically by debris, fallen trees, and even the poles or structures get broken. In renewables, in the moment of the hurricane, there were 8 small photovoltaic solar systems operating in the islands. The damage was total. These structures were designed thinking in a Cat 2 hurricane. We were talking about maximum 100 kilometers per hour. And in this case, we experienced over 250 kilometers per hour. So the structures, panels, and other equipment was totally destroyed. What we do after we get communication with the islands. Once the authorities developed the emergency plan, the idea was to recover the generation system the fastest possible. And we make a basic assessment of the equipment. And when the generators received some heavy rain, but it was in a good condition. So the drying process and all the measuring process to see if the isolation was working well start. Then we select one of the tanks. There were 5 tanks in that moment. We purge the fuel system, recover the pipe system, and we install emergency pump station. And immediately we start to test and recover all the transformer bay and the control system. In 2 weeks after the event, we run the 4th generation. Well, the generator was the biggest one, 1.4 megawatts. And in December 31st, almost a month and 20 days after the event, we get the second equipment online. For the distribution system, the idea was recover the medium voltage circuit the fastest possible to reach the airport. The airport is located approximately between 2 or 3 kilometers from the generation station. These were the point where they installed the emergency hospital and all the administrative and emergency center. So the idea was deploy all the personnel and equipment available to recover this part of the grid and at least have energy to supply the emergency assets. After this, when the personnel of the main island of the mainland from Colombia reached, we had support from companies as EPM and Cali, companies from all the biggest cities of Colombia. We deployed 4 teams that work in opposite directions. And finally, in December 31st, the 100% of the medium voltage grid was achieved. Why we deploy everything in the medium voltage grid? As the basic assessment give us the opportunity to see that the transformers and mainly the equipment could be energized. That will help the people to share energy, those hoses that was still intact, or maybe those areas where they can connect equipment to these transformers. So we deploy everything and every asset we had possible to recover the medium voltage grid. Was require less personnel, there was less equipment needed, and we can at least have some energy to share all around the island. The users, basically, after we recover the medium tension line, we start slowly because the damage in the wiring system of the low voltage system was very high. We start to recover those users that have their installation in good condition. We deploy connection boxes independent and metering to avoid risk of maybe any damage inside the hoses. And we recommend the people to share the energy to the neighbors, so everybody can have a little way to charge their equipment, or maybe have some opportunity to have freezers or save food. The reconstruction, finally the reconstruction took over in the electric part, took over approximately 5 months. In 1 month and 20 days, we recovered the medium tension line. The generation station was totally online in 2 months, and the low tension grid was recovered approximately in 5 months. Right now, we have approximately 75% of the users connected. Those users that are not connected are those that have totally damaged their houses, or their installation is not in the conditions to be connected. In this moment, the electric system in terms of demand is approximately in 70% of the normal demand. We are talking about 1.9 megawatt of demand daily. What we developed after the event, we deploy personnel to make an inventory of the whole system and make a deeper assessment. Mostly of the poles are concrete poles. We have some in fiberglass too. But the idea was to make a deeper assessment to see the state of these poles, make a physical evaluation of all the equipment. We use a GPS-based system, so we can make a total inventory of it. And we're gonna develop some improvements of the grid, trying to prepare for any other event like this for the future. What we learned in generation system, we need to reinforce basically the installations to heavy winds and rain. In this case, the wind wasn't the problem, was the rain. We have electric equipment that it can be exposed to water. So the rooftop of the installation have to be totally redesigned, and we have to try to make a case bunker to protect the equipment, because we experienced already a Cat 5 class hurricane, and this is a high level event. The fuel system going to be redesigned. We're going to have backup pipes and alternative pumps, and we're going to locate it above the ground level. This is why, because with the heavy rain, we have flood in the area, and usually these systems are above the ground, and we have to change the design completely. The shutdown of the system was a good idea. We learned this from beta in 2005. We're going to experience the same kind of damage for wind, debris, or fallen trees, but at least the electrical and electronic equipment going to be protected, those equipment that can resist the conditions, and also the human lives. In this case, usually they declare curfew for protect the people, but usually the emergency system and all the emergency plans are developed for personnel that is outside in the moment, and we can protect from any contact from energized wiring system or any falling poles. For the distribution systems, we're going to evaluate short-term runs of wiring. One of the biggest problems, especially in the medium tension wiring system, was the domino effect. Usually the fallen trees, debris, or even the wind that broke the one pole, the weight of this pole, maybe if it was in an angle, in a very high angle, they create a domino effect that affect 7, 8, or even 10 poles. So we're going to assess and we're going to investigate about if we make short-term runs, and we can use a mechanical braking system to protect the poles. We can reduce the damage, in this case, for falling poles. Also, the underground system is one of the best ways to protect the wiring system, but in terms of cost of investment, we have to evaluate which areas are more exposed to damage and to oversee if it's financially and operative costly effect develop this kind of system for the islands. As we said before, the shutdown of the grid reduced the electrical damage of the transformers. These equipments are heavy to get in this kind of emergency. They have to be made or deployed from the mainland. This will take 15 days basically. So the idea is to reinforce the structure, use heavy resistant poles to install these distribution transformers, and also deploy the shutdown in case of another event like this. Also, the user connections have to be protected by a mechanical braking system. We noticed that mainly the 80% of the damage in installation from users was made by falling trees that rip off the connection box, the metering box. So if we deploy a system, it can be mechanically braking and protect this equipment, could be less damage and could be recovered in a fastest way. For renewables, well, in the case of the rooftop design, it was heavily affected. Non-rooftop is designed for a level higher than 2 or 1 or 2 hurricanes. In this case, the damage was total, and some on ground basic structures never was designed for Category 5 hurricanes. All the projects we are deploying in this year to recover the system are basic with design for Category 5 hurricanes, and we try to deploy a system to install several projects all around the island with energy storage that can be deployed easy after one event of this. We're gonna talk further about Catalina Island project. We're gonna have approximately 1.5 kilowatts hour in energy storage, and this can be used in emergency very rapidly or very fast to deploy a shelter, a medical stations. So we gonna try to develop this kind of project, big project over 250 kilowatt peak install all around the island, maybe 4 or 5 of these projects, so they can be used in a case of emergency to serve energy to these emergency stations very readily in case of a further damage in the generation station. Well, like we say about Catalina project, the smallest island of our archipelago, we are talking about 85 users. They consume 20,000 kilowatts hour per month. We're gonna deploy a project of 250 kilowatts peak of the capacity installed, and the idea is to make this island 100% renewable. They're gonna have energy storage. They're gonna have 3 days of backup energy, and the grid going to be a backup plan for this island. We're gonna test here a structure, the design for 250 kilometers per hour winds, and the battery system going to be installed in a bunker system, or a bunker-like system to protect the energy storage. Also, in the new houses they're gonna deploy by the national government, they're gonna install 700 small residential system of 0.75 kilowatts peak of capacity with battery supply. We are talking about 100 amps hour of battery energy storage. And we're gonna deploy a smart control center to run these projects, because we're gonna have several projects, even a big one of 2 megawatts in solar, and we have to deploy a system. We are studying an experience that they have in Galapagos Island with Siemens, and they have a totally smart control system for the Isabela Island. We are looking on this to learn about what they deployed that, to see how we can install this in our islands. Incoming projects. Catalina Island. This project is going to be our first step to moving on to renewables. This island, as we said before, is the smallest of all the archipelago. We're going to have this system. We're going to install 1,420 kilowatts hour in energy storage. This can fill for 3 days of the consume of the island. We're going to have 250 kilowatt peaking capacity installed. And the idea, our goal is to reduce on a total of 310,000 kilograms of CO2 per year. Why we started the small island? The idea is based in the studies deployed by Rocky Mountain Institute and Carbon War Room in 2017. We can move gradually from our matrix that is 99% diesel or fossil fuel based, and gradually moving on to deploy renewables. The smallest island going to be 100%, is financially and technically feasible. In the Providencia island, we're going to move up to 70% of renewable penetration, and in the case of San Andres, that we have a higher consume and a high peak demand of 31 megawatts, you can reach financially and efficiently up to 50% in renewables. The goal in terms of 20 years is reduce about 50% of the subsidies that the government is applying. We are talking nearly sorting about 70 or 80 million dollars in this term of time.
Thank you very much. That was awesome. And a great point to finish on, 70 to 80 million dollars. So what I'm going to do now is I'm going to ask you guys a few questions that have been submitted. Those of you in the audience, if you have questions about the presentation, please share them in the Q&A segment, and I will ask the team. So we had a question coming in. I guess it can be addressed to all of you. Like, what do you think are some of your key barriers holding San Andres from building renewable energy so far? Like, what do you see as the first barrier that you'd have to address? The person asks if it's expenditure, if it's political, if it's knowledge, or if you don't see any barriers.
Sorry, Martin, could you repeat for us? What's the question?
The audience member wanted to know what the main barrier is for building or commissioning renewable energy that you see for your context across the islands.
Okay. As I say at the beginning of our interview or our presentation, there is at this moment a concession that was developed by the national government with a company, a utility company that is EPSA, and this contract go to 2030. So in matters of generating energy, commercializing it, and put it to work or using it, they have the contract signed, and as you say, monopoly of it. They are exclusive to the one that can do it. And in the behalf of this contract, they establish certain barriers or limits to develop technology in material of energy. They have in their contract they have to develop wind towers. They have to develop technology that have to do towards use of solid urban solids to generate energy, and that's the obligation that they have. So is a limitation, is a barrier for us in wanting to develop more technology in matter of clean energy. But what we're doing from EEDAS is working towards it in matters of seeing the frontier that is that 2030, that we could be prepared for a transition that coming towards us. Nationally, they are already doing it also. They just like 2 months ago, they issue a electric transition law to establish that process in the whole territory of Colombia. So that's what we're working towards, and that will be one of the first barriers that we can talk about. The other one that we see have to do with the educational part of the community. There is a lot of misconception of what renewables or using renewables could be in the benefit of it in the islands, or how to do it, or how to work along with it, and basically also in efficiency of the consumer of energy. So that will be like the two main barriers that we will see from EEDAS that have to be worked on, and that we're working on at this moment from the company vision. And that's what we're doing. We're doing small things, but with a big vision, and trying to in behalf of that, modify our matrix.
Thank you for that. Thank you for that. And someone wanted to hear a bit more about the waste to energy plant, like what the operation was like, if it's operational. But I guess, so I also had a question coming about like the challenges of running waste to energy. Did you get resistance? Do you get resistance to it from the community, or do people kind of understand the importance of it for the islands?
Well, in case of the community, in a heavily subsidized system like ours, had been complex to deploy renewables, especially wind. The people have difficulties to understand the benefits in terms of environment, in terms of financial reduction of the cost of energy, and in long-term stability of the system. Solar had been received in a good way for the community. Wind have been rejected until now because they are afraid of the size of these projects and maybe the benefits in terms of land use. We are studying maybe near offshore systems as alternative, but basically the heavy subsidized is one of the barriers we have to try to understand before deploy heavily the solar or renewables. The case of Carolina will open the door to show the community the benefits in long term of the renewable use, in this case of the islands. Maybe we're going to evaluate the gradual reduction of the cost of the light bill, but also the environmental benefits, and even in tourism, because right now we know there are very heavy concern in terms of clean tourism, and the idea of any tourist that will visit Carolina will be living in an area where the impact in terms of fossil fuels will be zero. So this is the work we are deploying, and this is the work from EEDAS. And that is our main goal, to try to get the way to the community to increase the use of renewables.
Yeah, no, I appreciate that.
I will also,
sorry,
excuse me, Martin, I will also, in the matter of what about urban solid waste and the machines and the work of it, and how the community reacts. There is something that we have to have in mind, or we like to express to you all with this system. As I explained at the moment, there is two different machines in the facility. One is one of them, which is the one that based on the WTE that have to do with the incinerating of the solid. And this machine was installed like in 2012 approximately. But there was a lack of planning when this went on, because they didn't organize well the part that have to do with the other machine, that is the one that separate and organize the solids, the solid waste. This machine for the solid waste was installed early in the end part of 2020, early 2021. So at this moment, what we're doing is we are in the period that adjusting one machine to the other and getting the system operable 100%. But and that create also a situation with the community, a resistance, and not too confident or have much confidence of the working of the system. But we already make the prove them. We already went through the evaluations, and we know that they're going to get the result that we're looking for. So approximately in a month of time, in the end of August, beginning of September, this machine will be 100% operational, and we will see the result and the impact of the result in the islands.
Oh, thank you very much, Randy. And I mean, like, just to contextualize how we came to be even having this webinar, I mean, you guys reached out to CARILEC because of the collective body of knowledge that exists among the utilities and your willingness to share, which I want to thank you guys for. Because as I see the questioning come in and seeing your presentation, a lot of the challenges that you're facing or a lot of the choices that you've made are very similar to other islands that I've seen through doing this work. And I guess it just had me wondering, like, from a capacity development in terms of like building your teams, are there, do you see opportunities for like other utilities to come and learn from you, or potentially, you know, like working together with you to galvanize these ideas and techniques and lessons a bit more?
Yeah, totally. That's one of our goals or objective, trying to be part of CARILEC and reconnect with the Caribbean islands and the Caribbean countries, especially because we have clear that that between us we are similar in territory, not as huge and as big as some of the islands in terms of Jamaica, you know, but we have the same problems in certain way, the social problems, the economical problems, so public service problems. So, and we know that in the Caribbean they have been developing certain activities in these matters, and we are willing to learn. We are willing to share our knowledge. We are open mind, open hands to share and to make networking, make alliance, whatever we have to do in order to get a betterment of our the development of the archipelago of San Andres, Providencia, and Catalina. And if we are the ones to have the opportunity to be part of the networking and share our experience with our neighbors in the Caribbean, that's our goal. We are willing to do it, and it can be back and forth. You know, that's our main idea. We know that the West Indies University have been working a lot about these things in the islands. We are very eager to exchange ideas with the academic ideas, with the utilities that in the islands. So we are here. That's our goal. And once again, Martin, thank you for this opportunity. You don't know how we are so excited to be here and to share our ideas with you all.
Yeah, I was so happy when you guys reached out, honestly, because even the fact that you know, like last year when everything was going on and we saw what was happening with disaster and everything, you know, it's like, now it's like we are, I want to say, leading in terms of the climate problem, in the sense of we're living and learning to lead through the experience of being hit by these natural disasters. And so aggregation of the lessons is definitely something. And like, I really appreciate that your presentation, you guys spoke not just to what you learned and your experience and sharing that so soon with the audience, but also, you know, open book on how we're going to do this with renewables, right? And I think that is the type of leadership that we want to see and the type of message that we want to share as CARILEC with our members. There were a few more questions that came in, but I know in the essence of time, I might, if you have like 5 more minutes, I could ask more questions, but if not, I would do the closing up poll and forward them to you.
No, that's no problem. That's no problem.
Okay.
We are here.
Okay. Okay. Because we had a lot start to come in at the last minute, which is usually the case. We had a question about like the rooftop system across the islands. If you could go back in time and improve the design of the rooftop systems that you saw destroyed, what would those improvements be? Or did you notice that some roofs were, did you notice a design similarity in the ones that were destroyed, or did you not really take note of that? Or how would you go about knowing that you want to put in this new infrastructure? Is there anything that you would change for your rooftops?
Well, basically, if we can go back in time, we recommend to deploy independent and ground-based structures. The rooftops of the mostly of 90% or even more of the houses here is not designed to these kind of events. And right now, the new design of the houses we are seeing in Providencia, we are waiting to see the early data to see if they can resist this kind of wind level. Because basically, as you see, the damage in the solar panels had been because the whole structure break down and separate from the house and destroy the solar panels. We see more resistance in some ground level structures, even they weren't designed to this kind of level of winds, but we see more resistance in this kind of system. That's why the Catalina project, we deploy a totally redesign of the system, increasing, it was designed to support level 3 hurricanes. Right now, the design is for level 5 hurricanes, and it's going to be independent totally from any structure, any rooftop, and our advice in this case of the 700 house smart system they're going to start is to make it independent of the house, ground level based, and in a structure that can receive the 250 kilometers per hour winds.
Thanks a lot. There's 3 similar questions that I'm gonna try and mix together into one for you. It's around, you know, like having gone through the disaster experience. What are some elements that you could see either EEDAS improve on if they were hit again, or the support that you got from outside, was it adequate, or were there areas where the support could improve in their process or timing for the disaster recovery? Or did you find that there were no really sticking points, but it was more just dealing with it all? And I know, like, in a disaster scenario, you're probably not even like thinking about that. So like, I'm very sensitive to to the fact of what you guys experienced. So just wonder if you had any thoughts about what we could do as a collective to improve the process if this were to happen to someone else or to you guys.
Well, one of the lessons we learned was basically when a city is designed, in this case an island is designed, the medical service, the emergency services, they never had taken in mind the grid. We forget about the electricity until it's off. What we learned from this is we need to plan better, deploy usually the hospitals or the emergency infrastructure is designed for a specific purpose, but we need to try to connect the electricity of the grid to this system so we can recover in the fastest way. In the case of the support that we received from mainland of the main island was adequate in terms of personnel. The problem was the logistics to get this personnel to the islands. We have seen this in other events in different islands. We see this in Puerto Rico and in Virgin Islands. Is the speed you can deploy the personnel and coordinate this personnel to reach the fastest way to recover the grid. In our case, we had the personnel, but the equipment needed, we are talking about cranes or heavy equipment, machinery to recover, clean the debris, and lift up the poles was very complex. The use of fiber poles, plastic poles, or other type of light equipment can help to recover faster. And we see the need, and this is going to be one of our proposals, is we need to create a team in the Caribbean of personnel capable to deploy in case of emergencies. We have linemen, we have electricians, we're well prepared, but sometimes they are not ready to deploy in emergency plans. So if we can connect all the islands through CARILEC and create a team that can support any island or any country in case of emergency, we'll have well-trained personnel capable to handle emergencies, prepared to achieve or work with the difficulties we're going to face, non-equipment, non-heavy equipment, no cranes, or maybe with difficulties of materials or even recycled material to recover fast the grid. This could be a strength in terms of the Caribbean in front of hurricanes. That will be one of our suggestions in this group.
Yeah, no, I agree with you. And I mean, we at CARILEC, we have a history of sharing resources through the CARILEC Disaster Assistance Program. But we've been having this discussion too about like, how do we even make it more impactful? And is having these type of discussions and even exchanges, and, you know, even looking at when last year we were talking about focusing also some attention on the soft, I guess you'd call them soft skills, but like the psychological training and the impact and the post-event psychological process and change management for utilities is something that we were looking at as well, especially since COVID. And you know, it's like every month there's something else happening, but that's what I say, you know, we're resilient leaders, right?
Right.
But I see that we're here at time, so what I can do is any extra questions I can forward on to the team, and also for the audience, this recording is going to be on CARIC on the platform. You have the ability to ask questions there. The team there are members of CARIC, so you can tag them there. We have a closing poll on that idea of collaboration. Before you go, we want to know, we'd like to know your willingness to take part in disaster recovery sessions. Once we've made our way through this 2021 hurricane season, like how interested are you in collaborating? And once we know that, we'll put your name on the listserv for anything that we design around this groupthink or working group type initiatives. I'll just give you a few more seconds before closing the poll. And yeah, so 91% are willing. So definitely be following up with your team. But honestly, Camilla, Edward, and Randy, thank you so much for organizing this, reaching out, and for sharing and being so open with your experience and also with your aspirations and goals. We hope to support you and connect with you any way we can. Have a good weekend.
Thank you.
Thank you, Martin. Thank you, CARILEC.
Cheers. Thanks, E.S.P.